Sunday, October 5th, 2025, AGNDD intelliReport topic, Otto Hahn. Please pardon any visual and informational inaccuracies in this entirely AI-generated article-based video. Otto Hahn, pioneering chemist from Frankfurt to radioactive discoveries. Otto Hahn, born March 8, 1879 in Frankfurt am Main, was the youngest son of glazier Heinrich Hahn and Charlotte. Educated at Klinger Oberrealschule, he developed a passion for chemistry at 15, convincing his father to let him pursue it over architecture. In 1897, Hahn studied chemistry at the University of Marburg with minors in math, physics, mineralogy, and philosophy. He spent semesters at Munich under Bayer, Muthmann, and Hofmann. He earned his doctorate in 1901 on bromine derivatives of isogenol. After brief military service, he assisted Professor Theodor Zinke at Marburg for 2 years. Otto Hahn, seeking industry work, joined University College London in 1904 under William Ramsay to learn English. There he discovered radiothorium, thorium-228, in 1905 while studying radium salts. Ramsay announced it at the Royal Society with media hype. Hahn published in the Proceedings his first of 250 radiochemistry papers. Advised by Ramsay, Hahn planned Berlin but first assisted Ernest Rutherford at McGill University, 1905 to 1906, overcoming skepticism about radiothorium's existence and half-life. In 1906, Otto Hahn returned to Germany and set up a lab in a Berlin woodworking shop, equipping it to study radioactivity. He discovered mesothorium-1 and 2 and ionium, thorium-230, with mesothorium-Y proving valuable for medical radiation at half the cost of radium. Despite skepticism from chemists, he became a privatdozent in 1907. At a physics colloquium, he met Lisa Meitner, initiating a 30-year collaboration. Meitner faced gender barriers initially restricted to the basement lab, but restrictions eased in 1908. In 1904, Harriet Brooks observed radioactive recoil but misinterpreted it. Otto Hahn and Lisa Meitner correctly demonstrated recoil from alpha particle emission. Hahn identified actinium-X, radium-223, a decay product of actinium with an 11.8-day half-life. He found that alpha emission from radioactinium, thorium-227, causes actinium-X to recoil forcefully, breaking chemical bonds, gaining a positive charge and collecting at a negative electrode. Meitner recognized this as a new detection method, leading to discoveries of actinium-C, thallium-207, and thorium-C, thallium-208. Walter Gerlach hailed it as profoundly significant. In 1910, Otto Hahn was appointed professor by Prussian minister August von Trott-zu-Sulz. In 1912, he became head of the radioactivity department at the new Kaiser Wilhelm Institute for Chemistry, KWIC, in Berlin-Dahlem, earning 5,000 marks annually, euro 29,000 in 2021. He received 66,000 marks, euro 369,000 in 2021, in 1914 for the mesothorium process, sharing 10% with Lisa Meitner. The institute opened on October 23, 1912, with Kaiser Wilhelm II present. To avoid contamination from prior labs, Hahn and Meitner enforced strict protocols. Separate rooms for experiments, no handshakes, toilet paper by handles, and dedicated storage for radioactive materials. Otto Hahn was recalled to German Army duty in July 1914, fighting in Belgium and earning the Iron Cross at Ypres. He joined Fritz Haber's chemical warfare unit, scouting sites for chlorine and phosgene gas attacks in Flanders and Poland, including Bolemau in 1915, where he led troops amid blowback and witnessed Russian deaths. Missions took him to Verdun and Italy's Isonzo front, aiding the Caporetto breakthrough. Between operations, he researched in Berlin. He was accidentally poisoned by phosgene and ended the war testing arsenicals. In 1913, Soddy and Phajans identified a gap in the periodic table between thorium and uranium, predicting ecatantalium. Phajans and Göring discovered a short-lived isotope, brevium. Hahn and Meitner, despite WY interruptions, isolated a long-lived isotope in 1917 to 1918, naming it proto-actinium as actinium's parent. Soddy and Cranston confirmed it but yielded priority. Its link to uranium-235 was found in 1929. Hahn and Meitner were Nobel-nominated. IUPAC named it protactinium in 1949, crediting them as discoverers. After WW1, Otto Hahn revisited his 1914 uranium decay experiments, detecting a radioactive substance with a 6-7-hour half-life in hydrofluoric acid solutions. Ruling out mesothorium-2 contamination, he identified it as a protactinium isotope, naming it uranium-Z, protactinium-234. It branched from uranium-X1, thorium-234, decaying to uranium-2 with a 6.7-hour half-life, while uranium-X2 had a shorter one. This marked the first discovery of nuclear isomerism, explained theoretically in 1936 by von Weizsäcker. Hahn was Nobel-nominated for this overlooked breakthrough. In 1924, Otto Hahn was elected to the Prussian Academy of Sciences and became deputy director of the KWIC, succeeding as director in 1928. He led the Chemical Radioactivity Division while Lisa Meitner headed Physical Radioactivity. In the 1920s, Hahn pioneered applied radiochemistry, using his emanation method for chemical research. His 1936 book, Applied Radiochemistry, based on 1933 Cornell lectures, influenced nuclear scientists in the US, UK, France, and USSR. Hahn is hailed as the father of nuclear chemistry. Fritz Strassmann joined Otto Hahn at the KWIC after rejecting Nazi affiliations, losing career prospects. Meitner helped hire him as an assistant, leading to collaborations. In 1933, Hahn praised Hitler in an interview during his U.S. visit. The civil service law ousted Jews from academia. Meitner was exempt. Haber resigned in protest. Hahn dismissed staff from Haber's institute, which shifted to chemical warfare. Disputes arose over Haber's funds and equipment for emigrating staff, resolved by Planck. Haber died in 1934. His memorial defied restrictions, attended by Hahn and others. In 1905 to 1906, Otto Hahn observed a rubidium-rich mineral from Manitoba and estimated Rb-87's half-life at 2 × 10 to the 11th years. He proposed dating rocks by comparing decayed strontium to remaining rubidium, superior to uranium methods due to helium loss. With Jacob Papish's help, he obtained samples. In 1937, Strassmann and Walling isolated 253.4 milligrams of senior 87 from 1012 G of mineral, confirming decay origins. Uranium dating estimated the mineral's age at 1,975 million years, refining Rb-87's half-life to 2.3 × 10 to the 11th years. Rb senior dating gained popularity in the 1950s via mass spectrometry. Following Chadwick's 1932 neutron discovery, Irene Curie and Frederick Joliot induced radioactivity in aluminum via alpha particles, creating a phosphorus isotope and extending radiochemistry across the periodic table. Fermi's team irradiated uranium with neutrons, believing they produced transuranic elements, Z92. Meitner, Hahn, and Strassmann investigated, identifying multiple radioactive products as elements 93, 96, but faced inconsistencies. They measured uranium-239's half-life and hypothesized new reactions. By 1937, publications highlighted chemical distinctions, yet Meitner doubted, suspecting uranium isomers or isotope variations in uranium-238. In 1939, Paul Hartek alerted German authorities to atomic bomb potential, leading to the HWA's control of the nuclear program under Kurt Diebner. Otto Hahn, at the Kaiser Wilhelm Institute, researched fission products, isotope separation, and uranium purification with his team. After a 1944 Allied bombing destroyed his office, the institute relocated to Tailfingen. Hahn protected colleagues with Jewish wives like Philipp Hearns and Heinrich Rausch von Traubenberg by deeming their work essential, though Traubenberg's widow was sent to Theresienstadt but survived. In April 1945, The Alsos mission arrested Otto Hahn and other German scientists involved in the nuclear program, relocating them to France, Belgium, and finally Farm Hall, England, where conversations were secretly recorded. Shocked by the Hiroshima bombing in August, they realized the Allies had surpassed them. They rationalized their failure, drafting a memorandum claiming moral superiority for not succeeding. Further stunned by Nagasaki's plutonium bomb, the group was released in January 1946 to British-controlled Göttingen. Otto Hahn was awarded the 1944 Nobel Prize in Chemistry on November 16, 1945, for discovering nuclear fission while interned at Farm Hall. He learned via newspaper and celebrated with fellow scientists. Nominated multiple times, Hahn alone received it, as the committee prioritized him over collaborators Meitner, Frisch, and Strassmann. Nazi rules initially blocked acceptance, but post-war, the prize was granted to assert independence. Unable to attend in 1945 due to captivity, Hahn received his medal from King Gustav V on December 10, 1946. After Albert Vogler's 1945 suicide, the Kaiser Wilhelm Society, KWS, was temporarily led by Max Planck. Otto Hahn was elected president and assumed office in 1946. Allied restrictions limited German research, and the KWS was dissolved in July 1946, deemed too tied to Nazis. The British allowed its continuation in their zone with a name change, opposed by Hahn and Heisenberg but supported by Bohr and Meitner. The Max Planck Society was founded in 1946, re-established in 1948, absorbing KWS institutes in Western zones. The KWIC relocated to Mainz in 1949. After World War II, Otto Hahn vehemently opposed nuclear weapons, viewing their use as a perversion of science. In 1954, he published Cobalt-60 Danger or Blessing for Mankind, warning of atomic misuse. He initiated the 1955 Mainau Declaration Against Atomic Arms and co-authored the 1957 Göttingen Manifesto, protesting nuclear arming of West Germany's Bundeswehr. Despite meetings with officials, Germany received U.S. nukes. Hahn gave anti-war speeches in Vienna and Sofia, co-founded the Federation of German Scientists in 1959, and tirelessly advocated for responsible science until his death, as noted by historian Lawrence Badasch. Otto Hahn met Edith Jungens in 1911 at a Stettin conference, becoming engaged in 1912 and marrying in 1913. After a honeymoon in Italy and visits to Vienna and Budapest, they had son Hanno in 1922. Hanno served as a panzer commander in World War II, losing an arm, then became an art historian specializing in 12th century Cistercian architecture. He died in a 1960 car accident in France with wife Ilse, leaving son Dietrich. In 1990, the Hanno and Ilse Hahn Prize was established by Rome's Bibliotheca Hertziana to honor young Italian art historians. Otto Hahn faced health setbacks in the 1950s, shot in 1951, injured in a 1952 accident, and a 1953 heart attack. He published Vom Radiothor zur Uranspaltung, 1962, English 1966, and began another autobiography but died on July 28, 1968, in Göttingen after fracturing a vertebra. His wife Edith died 2 weeks later. Obituaries praised him as the atomic age founder, highlighting his humility, integrity, kindness, and administrative prowess post-war. Tributes came from the Max Planck Society, Fritz Strassmann, Otto Robert Frisch, and the Royal Society. Otto Hahn, father of radiochemistry and nuclear chemistry, discovered nuclear fission, foundational to nuclear power and weapons. Praised by Glenn Seaborg for his monumental contributions, Hahn received the 1944 Nobel Prize in Chemistry. However, Lise Meitner was overlooked due to sexism, anti-Semitism, and disciplinary rivalries between chemists, physicists, and theorists, experimentalists. Post-war, Hahn's efforts to rehabilitate Germany's image drew criticism. Though not a Nazi, he tolerated them, making him complicit. Meitner described him as decent but lacking thoughtfulness and character strength in turbulent times. Otto Hahn, a pioneering chemist, was ranked the third most important scientist of the 20th century in a 1999 poll, behind Einstein and Planck. He won the 1944 Nobel Prize in Chemistry and numerous awards, including the Emil Fischer Medal, 1922, Max Planck Medal, 1949 with Meitner, and Enrico Fermi Award, 1966 with Meitner and Strassmann. Hahn held honorary presidencies, foreign memberships in academies worldwide, and doctorates from universities like Cambridge. Honors include the Legion d'Honneur and German Order of Merit. Named after him, NS Otto Hahn ship, lunar crater, asteroid 19126, and various prizes. Element naming proposals honored his legacy. Otto Hahn, a pioneering chemist, authored several key works. Applied Radiochemistry, 1936, Cornell University Press, explores radiochemical applications. New Atoms, Progress, and Some Memories, 1950, Elsevier, discusses atomic advancements. His scientific autobiography, 1966, Charles Scribner's Sons Trans Willy Ley, details his career including nuclear fission discovery. My Life, 1970, Herder and Herder, Trans Kaiser and Wilkins, offers personal memoirs. These books highlight Hahn's contributions to science. Under Rutherford's mentorship, Hahn solidified his radiochemistry expertise, paving the way for his Nobel Prize in discovering nuclear fission.
Thank you for watching this AGNDD intelliReport, dear viewers. Please like, subscribe, and click the bell button to get notified during new uploads. And make sure to tune in next time. Stay safe and healthy. Cheers!